I'm live. Well, hello everyone. So very sorry for the delay. We had some technical difficulties, but I intend on making it worth your while. And here we go. The most important thing I can say about model-based definition is if we don't innovate, we go by the wayside. This little webinar will be very quick. Hopefully it will be interactive as well. I hope to see your chats. I have a chat window there, and please ask questions anytime you like. And we were also going to make this material available at some other time, so you don't have to take notes. My name is Steve Samuel from Design Visionaries, and it's a huge privilege to do this. I'm going to go through this very quickly because I know that you're all very, very busy, and I don't want to waste your time. But the contents are going to be a little bit about DV, a little bit about the resources, the definition of model-based definition, incredible modeling techniques, etc. So we start off with model-based definition. What is it? And I have this little graphic here. Basically, one model rules them all. The complete digital definition of a product within a 3D model is what model-based definition is, and it has lots of ramifications. One model is created, so it's not ambiguous, and it contains manufacturing data, vendor notes, model test data, inspection data, etc. One model to rule them all. Just really quickly, I'll almost skip this part about myself. My name is Steve Samuel, of course. I've got a PE license. I've got a bunch of patents that I've done, and I've been the author of about 13 books on on CAD and model-based definition, etc., industrial design. I used to work at a company called Pratt & Whitney. I'm sure many of you have heard of Pratt & Whitney for 10 years, and I was a modeling specialist there, and I was a design engineer. It was a fantastic experience, a lot of smart people. And then I basically started Design Visionaries in 1993. I'm also a CEO of a company called US Tech, which is a nonprofit organization that enables young folks and folks who would not necessarily have the chance to learn CAD, and that's very, very rewarding. So, about Design Visionaries, the reason why we do this kind of training and the reason why I believe we're super qualified is because we have been doing design engineering and training for many years. Our motto is superior vision yields optimal products. And we have 4 products. We do design and build. We've got a manufacturing floor. We do training, computer-aided design training. We do NX, Creo, SolidWorks. We do staffing. And when we do staffing, I think it's superb because we train our folks so well because that's what we do. And then we do the model-based definition. Here's some of our satisfied customers. It's a small cross-section, actually, of the folks that we've served with the different services that we have, and we've gone all over the world as far as Singapore, Sweden, Australia, Denmark, Taiwan, all over the place, Japan. And so you can count on us to come to where you are and help you do this model-based definition. There's a lot to it, as you'll see. Here's some resources. If you go to our YouTube channel, you can learn more about model-based definition. We have a lot of free videos that talk about CAD techniques and model-based definition. So the question on a lot of folks' minds is why model-based definition? What's in it for me as a person who wants to get a product on the market? If you're a big company or a small company, there's a lot of huge benefits. Number one, you can save time on 2D drawings. That's really important. There's some automatic tools that I'll tell you about that can literally produce at the touch of a button a lot of the definition or a lot of the notes and callouts and dimensions that you would normally place on a 2D drawing manually. It forces you to make a better and more complete model. It supports the critical to function dimensioning mindset, which can really save a lot of time. It's a single point of truth that avoids a lot of confusion. It enables the tolerance stack-up analysis, the automated inspection and reports, better communication between cross-functional groups, many other automatic applications, and model-based definition query, which enables you to take a look at a 3D model or assembly and find out a lot about it that would normally be kind of tough, and it would normally have you make mistakes. And you can do some other things that I'll show you. And you can get the PMI, the 3D, the callouts, and the different, I'm going to call them product definition data items, validated immediately. And I'll show you a little demo of that. Some common problems to be solved with model-based definition are drawings that don't match up due to printouts and subsequent releases. So it's very, very common in the old paradigm of having a model and a 2D drawing or a PDF. It's very, very common for those to be out of sync. It's very common for people to print those out and have paper lying around the shop. And when revisions come, they don't always update. So it's really not good. There's drawings that don't match with manual text and things like that. When people get in a hurry to get their product on the market, sometimes they do drawings incorrectly, and they might literally put manual text on a drawing despite your best efforts. Drawings that don't quite point, or drawing dimensions that don't quite point to the entities that they're seemingly touching. You can't really tell in many cases on a 2D plot. And the time it takes to do 2D drawings adds no value these days because we have this better technique. And drawings that are not complete that go to manufacturing is a huge, huge problem. We all know that. We all know that the best laid plans of mice and men, you can have great checkers, you can have a great process, but still there's times when a drawing will go to a manufacturing partner, or even if it's internal, and there won't be enough on the drawing to really show the different entities and the different features, and then it'll have to go back and forth, and that wastes a lot of time. And then when you really think about it, when we're designing as design engineers, hopefully what we're doing is we're thinking in 3D, and then that's great, and we have these simulations, we've got these assemblies and these bills of materials, etc. And then we translate that to 2D, so we're basically taking a step backwards, and then we go from 2D to 3D again when we're actually building the part. So we avoid that. And then there's errors that can be made in the CMM programming, etc. So these are common problems that will be solved. Now, we have the pleasure of working with a lot of fantastic companies, aerospace companies, automotive, medical, consumer products, you name it. We've worked with so many companies that have been so successful. So what we've done is we've created a model-based definition ROI calculator. I'm going to make a bold statement and say, none of this is worth anything if you can't achieve one or more of the following: a faster time to market, better quality product for a reduced manufacturing cost, more time to perform analysis or more accurate analyses, better communication between cross-functional groups, or more reliable manufacturing with less scrap, or at least a more organized and standardized process that's better understood by all. So if you don't realize from model-based definition one or all of these, then it's not worth anything. But what we've done is we've put together a calculator that asks you certain questions, like how many people are in your organization, how many of them are doing 2D drawings, what are the type of 2D drawings that they're doing now, how is the whole process done. So you go through our calculator, and this is a redacted copy of a calculator or a calculation that we did for a company that we are presently working with, and they have 550 engineers. And as you can see on the bottom line of the calculator, there's a $12 million savings from model-based definition. So there's a return on investment paradigm that you can go through, so you really know before you actually spend any time embracing this new strategy, you have an idea of how much it's going to save you. In this particular case, we used the calculator, and we calculated the $12 million savings. Our customer took the calculator and did a bunch of things on their own to it, and they validated it in their own way, and they decided it wasn't 12 million, it was 10 million. But even still, that's really good for a model-based definition. And so away you go with the idea that if you embrace these technologies, it will really be good. So now let's get into the weeds. Let's get into the actual definitions here. So model-based definition relies upon a digital twin. And what we say is we want to model and we want to capture design intent from requirements all the way to retirement and all the levels in between. And we want to make sure that all the cross-functional groups can use the same definition, so there's no ambiguity and no changes. So the digital twin is necessary. The digital twin is an incredibly accurate model of what you're doing. It's an incredibly accurate model that is enabled by all of the fantastically powerful software techniques that we now have available. So we have amazing CAD. We've got, great tools. We can capture things parametrically, so we're actually modeling the design intent. So we don't capture just one model. We capture the whole design techniques and the design paradigms and rules and laws behind the models, so we can make very, very quick changes. We can capture things like the assembly movements, how an assembly actually works. In this case, it's a little device that opens up, and we can animate that, and we can do good kinematic analysis now, better than ever before. We can calculate the interactions or the iterations between electrical engineers, the mechanical engineers, the chemical engineers. We can really model things to a degree that we never could before. We could even capture things like liquids and glues and all kinds of weird multi-phase components and things that stretch. So these days we have the ability to model in a much, much better way. Color, texture, you name it, we can capture it all in a digital twin. And some of the things that are supporting elements is the rise of the accurate modeling. We have this thing called the technical data package, which allows us to take that rich three-dimensional definition of what we're doing and pump it out in the technical data package, so it's all packaged in one place, and we can transmit that to a manufacturing partner and make sure that there's no ambiguity and nothing is left. And I'll show you that in a moment. We can do staged models, which means that we can capture a model or a product definition data of a component from when we do a casting all the way to all the different machining operations and all of the different processes that may happen to that, even coatings, all the processes that happen to a single component can be captured in this staged model. And so that gives us a better way of really understanding and capturing the actual data. We do large assembly management, PMI, parameter tables, model-based design, model-based definition query, model-based definition advise. So these days we have these tools that enable us to have much, much better success. Now, model-based definition enables better and more advanced analyses. And this is really important because when we're trying to get a product on the market much faster, we've got to make sure that when we're doing our prototypes and we're doing our actual production models, that they've been analyzed to the nth degree in advance, so we can really not make mistakes. The very worst thing you can do, in my view, is release a product that has not been fully tested and have some problems out in the field that were unforeseen. And in order to avoid that, what we definitely want to do is make sure that we've done as much analysis as we can. This can be finite element analysis, tolerance stackup analysis, CMM analysis, or CMM simulation. A lot of simulations and analyses are now available because we have models that are more robust and have more information in them. And so that enables all of these different techniques. It's fantastic. And we have a powerful new way to model, which also enables us to capture the modeling so much more exactly and make sure that the models that we have are of better quality to begin with. We've got this new way of being able to model things called algorithmic modeling, where we can create a basic program, if you will, that takes an input like a modeling face and can do all sorts of things. So for example, here's a piece of geometry that would be very, very difficult to create if you did not have algorithmic modeling, a way of programming the model with little blocks of programming and inputs and outputs that you can put together in minutes. And then you have the ability to create these very, very complex and very powerful features, put them in your library, and have them available to everyone. So this is a very, very important part of the ability to model things as exactly and specifically as you need to support your model-based definition. Another example is from the aerospace industry. In many cases, if you have some sort of airplane wing or a flap, what you do is you bring in your OML, your outer mean line surface, and then you have to start making ribs. Well, this little program that it took me about 15 minutes to put together with all these little programming blocks basically has you select the face, the OML, the surfaces. It has you select a plane where you want a rib, and then you go through and you tell it the rib thickness, and you tell it the web thickness, and all these different inputs, and out you come with a rib in minutes rather than the hours and hours it may take you if you were doing it without algorithmic modeling. And so there's ways to organize those programs and manage the nodes, etc. So those are all part of it and part of the training that you would normally have if you're going to embrace model-based definition. And model-based definition relies on your product lifecycle management system as well. If you have Team Center, if you have the ability to create variations of models, and you want to organize them, and you want to make sure that you model not just the part, but the whole litany of things that were modeled to get the part to you. If you're a medical company, you really need a design history file, and you need to keep the records of things like that, and you really need to capture processes and all sorts of things. Instead of thinking about a assembly as a number of components that just fit together, 3D CAD files, we really should be thinking of items. An item is a container that holds not only the product definition data for the mechanical design, but it also holds the non-shape data, the processes, the different kinds of notes and supporting documentation that would go along with each component. So PLM plays into model-based definition as well. We all want to make sure that everything is captured, all the details. So then that brings us to the logical editor, the model-based definition logical editor. So in the same way that we can program these models in the algorithmic modeling process, where we can have these routines that actually create the geometry for us, we can also have the model-based definition editor, so we can create these logical rules. And with the logical rules, you pick out nodes, just like the programming that you do with the algorithmic modeling. That's why I showed that to you as well. And what you can do is you can have your models automatically annotate themselves. So I'm a design engineer, a real nerd. I love to design things. I love to hand sketch things. I love to build things even with my hand or my 3-axis milling machine or whatever, but I really have never loved the 2D drawing phase. I've never really, it's just this thing that you have to do. But when you avoid that, when you want to avoid it, when you want to save all of that time, it's fantastic to have these tools where you can program them or use the ones that just come with the software. And for example, here you could use the find hole technique. So you just do one click on your model, you feed it this body, and it goes through the different programming blocks. There's very few here, and it makes all the hole callouts for you. So that's fantastic. So just imagine if there's holes, there's chamfers, there's blends, there's all this stuff, there's ribs, there's all these things that you might, in the, let's call them the old days, annotate on a 2D drawing with a PDF. And now you can do it in 3D with PMI. And you can make sure that that process is really streamlined. Now that brings us to another fantastic piece of the puzzle, and that's the PMI advisor. So here we have a model that has all of these annotations on them, and some of them I've purposely made incorrectly.
Hello everyone, my name is Steve Samuel.
So here's a little video. I think I'll turn the sound down and just kind of explain it to you. And here's a little video of a example that I've done where I've got all of this PMI, product manufacturing information, on a model, all the dimensions and so on and so forth, and I've purposely created some that are wrong to show you that in NX you have this thing called a PMI advisor. And when you click on the advisor, here we go, here's me clicking on the advisor, and the advisor automatically shows you all the things that are wrong with the PMI that you've placed on the model. So for example, there's a dimension that doesn't have any tolerances on it. There's here a GD&T call out that is perpendicular to plane A being this face right here that's being pointed to, but the actual surface is not perpendicular to plane A, so it's an incorrect PMI. And so these are the things that the PMI advisor will capture or show you immediately. So what that means is there's a very, very easy way to validate the PMI that you're putting on a model, which means in turn that when it goes to manufacturing, it's going to be of better quality. And the buzzword for many, many years, or I should say the buzz phrase for many years, is get it right the first time. If you get it right the first time, it just has this exponentially positive impact on the downstream applications. So there's the PMI advisor. So that's fantastic. Another thing that is enabled by the latest powerful software that we have is staged models. So for example, here's a model that was built with a casting. The casting is how you get these as cast surfaces. So just imagine like it's an airfoil or some piece of geometry that's highly sculpted, but also has mount holes and things like that. In the aerospace industry, it's very common to have single growth crystal turbine blades. They're so strong, amazingly strong, and they're cast with this little pigtail thing, and it makes one big huge a crystal basically of a component. But you can't get the fine holes like that, or if you have threaded holes or whatever, so you have to do these second operations. And so when you want to model all of that and make sure that all of that product definition data is well book kept and well represented, you need staged models, and so you have that. Now, the benefits that you get from what they call tolerance stack-up analysis are amazing. If you've got a number of components that fit together and they all have their basic tolerance on them, and you want to know what happens with the interaction of those tolerances, in the old days, what you'd do is you'd get out your spreadsheet and you'd look at the tolerances at the different one and you'd add them up and you'd max them out, and you'd do a min study and so on and so forth, and you'd get kind of an answer, but it wouldn't be a great answer because you wouldn't necessarily be able to do a Monte Carlo analysis, a real statistical analysis with a hysteresis curve, and find out where 6 sigma would be very easily. It's just really, really time consuming. But with the ability to put PMI, product manufacturing information, on individual models and all of the GD&T callouts semantically on surfaces, and when I use the term semantically, what I mean is these callouts are placed on the model in such a way that there's knowledge of the actual surfaces and what they would do on the actual surfaces themselves, not a representation of the surface. So when you do that, when you place the PMI correctly, you get the benefits of time savings because it's going to be automatic, which I'm going to show you almost in real time. You get a more realistic tolerance scheme. You get to find out exactly what happens because of your tolerance stream. You get to review it. You get to see it in real time, and it's just amazing. So here we go. Just imagine that this little component on the left-hand side has a 1.5 inch height with a 0.25 plus or minus tolerance. Now that's a huge tolerance, but I did that because I just wanted to show you that the modeler can now take your model and I'll say perturbate it, really show you the result of what happens when you have different tolerance schemes in real time, just like that. And the beauty of this is you can very easily use the plugins. I'm going to show you a plugin where in this little video, what we're doing is I have an assembly that's just made out of 2 plates. I just want it to be very simple to show you the possibilities. And I'm going to skip through this because I'm running a little low on time here. So what happens in this video is, and you can get this online, is you use a wonderful, wonderful plugin called 3DCS. And what happens is you put your tolerances, you put your GD&T callouts, and etc. on the individual components themselves, like this. And then when you have the assembly, you submit the assembly to 3DCS, and it automatically grabs all of your callouts and your tolerances from the individual components themselves. That's awesome. And then what you can do is you can do a thing called deviate or sweep, where you can actually see in a mesh format exactly what's going to happen with the components as the tolerances are applied to the assembly, not just the individual components themselves. That's amazing. And then you do this thing called a measure, which allows you to figure out what kind of dimension scheme you would want between the stack up of different parts, and you give it your limits. You figure out, like, if this were a display screen with a bunch of layers of the different things that are in the display screen, you give it right here. I'm showing you a 0.15 and a plus or minus 0.15 inch tolerance for the whole space that this wafer, if you would fit into. And then finally, you can do this report. You can have it do 1,000 or 2,000 iterations, which will show you exactly how many, if you really manufactured these parts, how many of these parts would actually be scrap, or how many of them are within the 6 sigma that we all talk about in terms of quality. So this happens automatically. It saves you tons and tons of time, and it gives you a more realistic view of exactly what happens. So that's 3DCS. There's another way that you can do it called VCS. It's a wonderful plugin that is a Siemens product. And as you can see, I've got another example of an assembly. I'll skip through that because I'm running low on time. And I've got an assembly where we're trying to figure out the clearance between this little blue ring and this gray part. And again, we get a similar report on the actual clearance. So it would be very, very difficult to do that by hand. Okay? Then we talk about the vendor piece. Once you embrace these model-based definition techniques, it's fantastic. It's really powerful. You save all of this time. But then the big question is, what do you do for the vendors, especially vendors that aren't necessarily in-house, and especially folks who are quote-unquote mom and pop shops? So there's an answer for that. So what does the vendor need to be successful? They need the format and the protocol. They need to get the files in the right format, whether they're Step 242 or 3D PDFs or JT. They need to get the automatic inspection techniques down. So they might, have to retool a little bit of their software. Hopefully they have a CMM. They need the raw data in a way that they can understand. Maybe they have a portal into Team Center, a vendor login. That would be great because that means they can give you feedback. So there's a lot of things that can happen between OEM and manufacturer, CMM programming, et cetera, et cetera. And I'll skip a little bit of this, but in the end, what they need to have is a powerful display screen by their machine tool, so they can bring this stuff up in 3D and we can get away from the whole 2D drawings thing. Then we have the ability to do the technical data package. The technical data package allows us to take all of this data and package it in a wonderful one file, has everything format. So you package everything up in the technical data package, and you get a 3D PDF. There's a little video that I've done that's on my YouTube channel that shows how to use the technical data package. You can make a profile for your company, then you can go through and you can export all of this data. See, it has a literally 3D ability. You can do the technical data package where you can rotate this and you can query and you can do measurements and you can package other stuff. So there's the TDP, technical data package, which is part of the picture, the use of the technical data package. And then there's the automatic CMM programming that is fantastically powerful as well. And here's an example that I have. It's a video, and this is going to be on the YouTube channel as well soon, of how once you have the PMI on your components and on your assembly, you can literally have the CMM programming be virtually automatic. And here is a sample of the fact that we have this software available. It's a Siemens plugin that does the CMM programming. It saves you literally weeks and weeks of time to do that because it's so automatic, and it's predicated on the ability to do the semantic PMI, to actually put the PMI callouts on surfaces, not just edges. So there's that. There's JT2Go, which is a very, very powerful piece of software that is free. So if you're a vendor and you want to know what to do with all of these files that you get, you have this JT2Go. If you're not very sophisticated and you don't have the wherewithal to get a Team Center login so that you can communicate with your OEMs, as the manufacturer, you can use JT2Go. And so this brings us to what do we need to do to proceed? Okay, so to adopt model-based engineering and model-based definition, we need training. We need to create great material that's custom, that is streamlined and comprehensive. We need trainers who know their material extremely well, and trainers who've been in the manufacturing process and the design process and the inspection process and know how to do analyses. We've got to have a person that we will assign you if you give us the privilege of working with you, that has a lot of experience doing all of this and a lot of experience with processes. And the course has to be taught in real time with your parts. And then there has to be mentoring afterwards. And then when we do these processes, we really have to measure the efficiencies because there's a lot of money saved. It's incredibly powerful. And when you measure the efficiencies and you measure the new processes, you invariably can find that you're saving a lot of time and a lot of money. And that's a very important part of the whole process. It's very important to overcome the stationary momentum. The folks who really would love to just do exactly what they've been doing for many years. But then you go back to the very first slide, which says Innovate or go by the Wayside. This is a slide that shows you that there's kind of a model-based definition, modus operandi. If you really want to do a good job, there's an engagement kind of procedure where you take the initial, you do initial studies and you go through and you have certain interviews and there's certain kind of milestones that you hit. So there's kind of a way that we have seen to be successful of going through all of this, so we can certainly help you with that. I'd be remiss if I didn't tell you that at Design Visionaries, there's some resources available. We've got some published works on this. We've got some model-based design, model-based definition tools that we've created. There's a bibliography to this whole talk. There's a bunch of books that if you read them, you'll be much more knowledgeable on the whole thing as it goes. And so there, I've gotten to the end of the talk. This has been about 50 minutes. I'm so sorry for the technical troubles that we've had in the beginning. But what I can do now is open this up to questions. Hopefully the questions will come up on the chat stream. I've been talking. I'm very, very excited about all of this, as you could imagine. And so I'm looking for the questions in my chat. But as you can imagine, this kind of work is incredibly challenging, but incredibly rewarding, because what we've found with other companies that we've worked with is we can really save them a lot of time. And that is always a fantastic feeling, to know that what we're doing is really enabling people to get their product definition data more communicable, let's say, to the different cross-functional groups, and to save them all this time and money and get their product on the market faster. And what I've said today is predicated on 30 years of experience running Design Visionaries, and 10 years before that as an aerospace engineer. And I know that a lot of this stuff, when you look at things like this, it's really got to be real. It's got to really save the time, and it's got to really be predicated on experience. So I'm looking for questions. Oh, I've got a comment. Very nice. Thanks for that. One question that I always have is, how do I get started? And of course, you get started with doing a survey and documenting the processes that are being done, and looking for the efficiencies in between the processes, if you will. It's always really good to take a look at what people are doing and look at the inputs and the outputs of various groups and try to optimize what's happening. When I used to work with jet engines in a very fantastic company called Pratt & Whitney, it's no secret, we used to do this thing called a front to back meeting. And you know, a jet engine has a spinner cap, and it's got these fan blades, it's got a low compressor, a high compressor, it's got a bunch of stuff, a burner, then it's got the high turbine, the low turbine, it's got all this plumbing all over it. And what we would do is analyze what was happening between the different groups and take a look. Well, model-based definition enables that greatly, because every single group, input and output, can use the same models, and they can get looks at the models before they're finished, and they can give their input to different groups. And when you ease the communication, it gives this huge advantage. So with that, I'm pretty much 5 minutes over time. I want to be respectful. I know that you're all very busy, and to spend this kind of time with us is gold. Thanks very much. You can obviously call us. We'll help you go through this process. We'd be really glad to do that. Think of us as this huge resource. And also, the Design Visionaries YouTube channel is there with hundreds of videos that talk about model-based definition and other things. So I'm getting folks that are chatting me. Thanks. You're so very welcome. Thanks for your time. Again, this is Steve Samuel from Design Visionaries, and I hope you think of us as your resource. Thank you very much.